Hi to you watching this video. So for this video, we're already on Unit 1, Infiltration, but we are still on Module number 1. So we are going to discuss infiltration. So what is infiltration? So infiltration, it is the flow of water into the ground through the soil surface. Or in short, it is the process of the precipitate to penetrate our soil, to saturate our soil, and to navigate our soil particles, our rock surface through voids. Okay? So ito yung process kung saan nagna-navigate yung water particles natin sa ating subsurface. So we can categorize infiltration into two categories. So we have here the low intensity rainfall and we have here the high intensity rainfall. So if the rate of supply of water of the surface is less than the potential infiltration rate, then actual infiltration rate will be less than the potential rate. So the definition here, which is F1, F is equivalent to I when I is lower than FP, or the potential is low intensity. Ibig sabihin, if the low or the rainfall is not that hard, wherein we have here a soil moisture storage capacity, this is the maximum where the soil can store water pag umuulan, and pag hindi yan na saturate or hindi niya na reach yan, then there is a low intensity rainfall, thus it does not contribute to water ground flow, or groundwater flow rather. Okay, compared to a high intensity rainfall. So if the water is ponded on the surface, the infiltration occurs at the potential infiltration rate, where F is equivalent to FP when I is greater or equal to FP. So what do we mean? Like for example, it is raining hard, no? It is raining hard that the soil moisture storage capacity of the soil is exceeding its limit, or it has reached its limit, and pag na-exceed niya na yan, then of course due to gravity din, the flow of water is downward. Therefore, it contributes to the recharging of the groundwater, thus creating a groundwater flow. Okay? Like for example, this is the storage capacity of the soil, but since we have a high intensity rainfall, then nagkakaroon tayo ng malaking volume ng water that is being dumped into the surface area. So since it has already reached its capacity, yun, bababa yung water particle natin, it will help in the groundwater recharge, thus creating groundwater flow, and at the same time there will be a surface runoff kasi hindi lahat ng yon magsisip in dun sa soil natin. Okay? So most infiltration equations are described by B, where I is always greater than FP. Okay? FP is the potential infiltration rate. Here are some factors that may contribute or affect the infiltration rate of a water. Okay, so first we have the condition of soil surface and vegetative cover. When we say condition of soil surface, what we mean here is the material of the the surface. Like for example, we have a soil and we have a concrete, no? Now, if we are going to compare the material between a concrete and a soil, we can say that the material for soil has more voids in it, and it is more permeable compared to a concrete, which is less permeable versus the soil. Therefore, from there, we can say na mas mabilis yung pagsip ng water, or yung pagpass ng water, or infiltration of water through the material of soil versus the concrete. Okay? Next is the vegetative cover. So when we say vegetative cover, it is the presence of plants, grass, trees. Yan. So we know that this materials can impede the rate of infiltration, may it be vertical or may it be horizontal. Okay? And we can also consider here the topography. So from your higher engineering surveys, or CE 14, if you can recall the topography, the more slope we have, the more chances of that the more chances that we will be having a surface runoff compared to a flat terrain. Pag flat terrain lang siya, there is a nag-stick lang yung or nag-stay lang yung water sa surface, then saka siya magsisip through. Compared pag slope siya, then there is a higher chance of water runoff. Next would be the soil properties. So we have here the porosity and the hydraulic conductivity. So when we a good example of this is when we have sand versus silt. So we in a soil rather, we have the silt, sand, and clay, or it can be a combination. Now, if we are going to have a comparison between sand and silt, sand and clay, we know that sand does not carry or does not absorb water compared to a clay particle. Wherein, pag nabasa ang clay, nagka-absorb siya ng water, it can expand versus a sand wherein mas malalaki ang void spaces natin where from there masasabi natin na mas mabilis na magpe-penetrate yung water compared sa clay na mas maliliit yung particles na pag nabasa it can expand, thus slowing the rate of infiltration. Okay? And when we say hydraulic conductivity, it is the easiness of water to penetrate or to seep through the voids. Next is the current moisture content of soil. Now, why is this important? Like what we have said kanina, we have a soil moisture storage capacity. Now, when the soil moisture storage capacity of the soil is already exceeded, or if na-saturated na yung soil natin, mas mabagal na yung rate of infiltration natin. Why? Because the voids on the void on the soil profile is already occupied. But due to force of gravity, the weight of the water is being pulled downward, thus creating a groundwater flow. Okay, so nagkakaroon tayo ng groundwater flow, nare-recharge yung groundwater natin, but it is slower because take note, the voids on our soil profile is already occupied compared when a soil is just moist or when the soil is dry. So mas mabilis ang infiltration yan kasi yung mga voids natin air lang siya. Okay? So, mas mabilis na makakargahan. So, mabilis na magsisip yung water natin. Okay? And next is the soil strata with different physical properties may overlay each other, forming horizons. Now, if you can recall from Geotechnical Engineering 1 or Geotechnical Engineering 2, and if you had the opportunity to excavate for your soil sample, if you can recall them, wait, let's see if magda-drawing ito. Okay, so for example, your footing will be placed from a certain depth. So ito yung hinukay natin. Why is it important for us to determine the bearing capacity at this level? It's because dyan natin ipapatong yung foundation natin. Yan yung magki-carry. Because it might happen that the soil profile at this level might be different with the soil profile at this level. Okay? So, it might happen that for example, the soil profile here is made of silt or clay. Hindi ibig sabihin na porket clay na sa level na to, clay na rin yung nandito sa ilalim. So, the soil properties is varying depending on the depth. Thus, we have a soil strata. Okay? So, we have a different soil profile here. We have a different soil profile here. We have a different soil profile here. Thus, creating or giving us a different soil properties. Therefore, affecting the rate of infiltration. Okay? Next, we have here the distribution of soil moisture within the soil profile during the downward movement of water. Okay, so I repeat, it is during the downward movement of water. So, we have here the cross-section of the soil profile, and it shows us here 4 different zones. So, we have zone 1, zone 2, zone 3, zone 4. We have here the x coordinate and we have here the y coordinate. Okay, so x coordinate is along the plane surface, and y coordinate is the depth, representing the depth. So for take note, this is the diagram during precipitation. Okay, so for zone 1, we have here the saturated zone, a thin layer near the surface. So of course, when it's precipitating, or for example we have rain, if it's raining, of course the first thing that will be saturated will be this first zone, or yung nasa mismong surface, or yung pinakamalapit sa ground surface natin, which is exposed to the precipitation. Okay, and next would be zone number 2. Now, for zone number 2, we have here the transition zone. So this shows the variation in moisture content along the wetting front. Okay, so we said kanina na saturation zone would be the most what do we call this, would be the most or easily saturated or easily infiltrated, because the layer here, zone 1, is loosely compacted material. So as we go deeper, mas nagiging well compacted na siya. So if the soil profile is loosely compacted material, then we have many voids. So marami tayong spaces. Okay? So if that would be the case, then it would be easily occupied by water molecule. Okay? So for zone number 2, this shows the variation in moisture content along the wetting front. So here sa saturation zone, medyo maraming water content. Then as we go deeper, papuntang transmission zone, mas nababawasan. Okay? Due to a factor also that is being contributed by the compaction. Next, we have here zone number 3, where it is the transmission zone. Now, here we have the moisture content, MC, is above the filled moisture content, but below the saturated content. So, when we say filled capacity, it is, or FC, or it is the amount of water that a soil can hold after excess is drained away by gravity. So, when we say filled capacity, ito yung kayang buhatin lang or i-carry ng soil. So, pag moist naman, may content siya na water. But when we say filled capacity, ito lang yung kayang buhatin. When we say saturated, ibig sabihin yung voids natin na fill up na ng water. Okay? So in this zone, our moisture is on its filled capacity level, but it is below saturation content. And zone number 4, we have here the wetting zone. The moisture content is near the filled capacity and decreases with depth. Okay, so moisture content decreases with depth. Of course, I repeat, this is during precipitation. So habang palalim ng palalim, it is expected that mas konti yung presence ng water. Okay, but iba yung case when it has already stopped precipitating. Like for example, after bumagyo, magiging iba na yung scenario, wherein the water on the ground surface has already infiltrated our soil profile. Therefore, mas marami yung tubig natin nasa ilalim la, like what we can recall from our geotechnical engineering. When we have groundwater table, the soil below the groundwater table is saturated while the soil above is dry. So that applies here after precipitation. Okay? Yan. So we have here the legend. MC is moisture content, FC is the filled capacity, and SC is the saturation capacity level. Now we have here the different methods that we are going to use in order to solve for the infiltration rate. Okay? So starting off with Horton's equation. So Horton in 1933 showed that when rainfall rate I exceeds the infiltration rate F, water infiltrates the surface soil at the rate that generally decreases with the time as shown by the figure. So, as according to Horton, as time passes by during infiltration, habang tumatagal daw, pababa ng pababa yung infiltration rate natin. And it is shown in this graph. So we have here the y-axis as the infiltration at capacity rate, and at the x-axis the time from the start of infiltration. So F is equivalent to Fc plus F sub 0 minus Fc raised to Euler's formula, times Euler's formula raised to negative kT, where F is the infiltration capacity. F naught is equivalent to the initial infiltration capacity. Fc is the final or the equilibrium infiltration capacity, and K is the empirical constant. So we have here an illustration to demonstrate. So the initial infiltration capacity of a watershed is estimated as 1.5 inch per hour, and the time constant is taken to be 0.35 per hour. The equilibrium capacity is 0.2 inch per hour. Use Horton's equation to find, letter A, the values of F at time 10 minutes, 30 minutes, 1 hour, 2 hours, 6 hours. And letter B, the total volume of infiltration over the 6-hour period. So first, we need to identify our given. So what are the given? So according to our problem, we have here an initial infiltration. So that is FO, which is equivalent to 1.5 hours, inch per hour. Okay, so that is our FO. Next is our FC. So what? So FC is equivalent to the equilibrium capacity is 0.2 inch per hour. So therefore, this is our FC, and our empirical constant happens to be 0.35 per hour. Okay. Yeah. Now going back to our equation, Horton's equation is this. So we copy this, then we paste it here. So this is our working equation. So we need to determine for letter A, we need to determine the different infiltration capacity on this given times. We have the 10 minutes, 30 minutes, 1 hour, 6 hour, 2 hours, and 6 hours. Then since our constant or our values here are in inch per hour, we need to convert our time. So 10 minutes is equivalent to 0.1667 hour. 30 minutes is equivalent to 0.5 hour. So we can now write our equation. So FC is equivalent to 0.2 plus we have FO or F naught 1.5. So 1.5 plus what is minus what is FC. FC is equivalent to 0.2 raised to times Euler's formula, or E. You can simply find that in your calculator. Raised to we have K, empirical constant of 0.35 times we have times the time of 0.1667. Okay, and that is equivalent to, actually pare-parehas lang yung ating equation, it's just that it will be different in terms of time. So pwede nating copy paste. Okay, so then mamaya palitan na lang natin yung time. Okay, so bring out your calculators, sabayan nyo ako. So we have 0.2 plus 1.5 minus 0.2 times Euler's formula raised to negative 0.35 times alpha x. So calculate. So what is the value of x? 0.1667. Therefore, the F here is 1.5 4,263, and that is in inches per hour. So inch per hour. Next, we have here that the time is 0.5. Palitan natin yung 0.667. Okay. Then calculate. It is equivalent to 1.2913. And that is again is in inch per hour. Next, yung time natin dito, palitan natin. That should be times 1. Okay. So calculate. That is 1.1161. Mali. 1.1161. That is in inch per hour. Next, the time here is 2. Let's change that to hours. And then dito rin, palitan natin. So this is 6. So yung infiltration rate natin dito is equivalent to 0.8456. That is in inch per hour. Then lastly, at 6 hours, our infiltration rate is 0.392. That is in inch 3592. 3592, that is in inch per hour. Take note. Okay, so take note that if you're going to see, rather, if you're going to observe, habang patagal ng patagal yung time natin, the infiltration capacity decreases. Okay, so nababawasan yung infiltration capacity natin. Because, like what we have said a while ago in our earlier discussion, the voids the voids are already being occupied. Okay, so kaya bumabagal yung infiltration. And due to compaction din. Okay, now that is only for letter A. Now, how about for letter B? So, for letter B, we need to determine the total volume of infiltration over the 6-hour period. So, what is the total volume of infiltration? Now, we can solve that in two methods. First, we have the graphical method, and next, we have the modified equation. Now, for graphical method, we are going to simply plot. We are just going to plot. Along the y-axis, we have here the infiltration. Along the x-axis, we have here the time. So, at 10 minutes, we have 1.4263. So, plot natin doon. At 0.5 hours, dito yon. At 0.5 hours, we have 1.2913. Okay? Next, at 1 hour, so we have here at 1 hour, the infiltration is 1.1. So, nandito yon. At 2 hours, so at 2 hours, the infiltration is 0.8456. So, nandito yon. Then, at 6 hours, the infiltration here is 0.3592. So, it is roughly here. Then, yung mga points, we connect that by a curve. Now, the area below our curve and bounded by the x and the y-axis would be the volume of the 6-hour period. Okay? So, dito, yan. Through graphical method. Now, another method is by using the modified equation. So, here we have our equation here is F is equivalent to FC plus quantity f of naught minus FC times E raised to negative K. So, we get the integral. Okay? Or the differential, rather. Or yeah, tama, integral, sorry. By integrating Horton's equation, we therefore get f prime is equivalent to fct plus f naught minus fc over k times 1 minus e raised to negative kt. So using this equation, we can now get the value of the volume for the 6 hours. Okay, so substituting, what is our fc? fc we have 0.2. So we have here 0.2 times the time, which is 6, plus what is our F sub O, F0 and FC. F 1.5 minus 0.2. So 1.5 minus 0.2 divided by what is our constant. Our empirical constant is 0.35. So 0.35 times 1 minus E raised to 0.30 negative 0.35 times 6. Okay, so bring out your calculator. Dapat ang lalabas dyan is now to check whether our answer is correct, we can use the first method, which is by graphical method, by integrating. So we have here our original equation, which is F is equivalent to FC plus FO minus FC times E raised to negative KT. FC natin is, what is FC? 0.2 plus, we have here 1.5 minus 0.2 times E raised to negative 0.35 times T, where our limit would be from 0 to 6. Okay, so we integrate that. Because F here is a function of X, so this is a function of X, so we integrate that. We should arrive at the same answer. So 0.2 times 1.5 minus 0.2, that is 1.3, times E raised to negative 0.35 times time. And our time here, time is from 0 to 6. Okay, that would be our limit. So dt. Therefore, F prime is 4.4594 inch per hour. Next would be by Phillips equation. So in 1957, using analytical solution for unsaturated flow. I repeat, it is for an saturated flow, developed two equations of the system. So using analytic solution, he was able to come up with two solutions. So F is equivalent to 0.5 S times S times T raised to negative 1/2 plus K. And F is equivalent to S times T raised to negative 1/2 plus K times T. Where F is the infiltration capacity, F is the cumulative infiltration volume, S is sorptivity, a constant related to soil suction potential, and K is soil hydraulic conductivity. So another infiltration method is the use of phi index here. So it assumes that infiltration loss is uniformly distributed across the rainfall pattern, where the area above the phi index sums to the volume of direct runoff, and the area below sums to the volume of infiltration. Okay, so to understand that further, let's have an illustrative problem here. So use the rainfall data below to determine the phi index for a watershed that is 0.875 square miles, where the runoff volume is 228.7 acre feet. From the water balance equation, infiltration when taken away from precipitation is equal to the runoff depth. Since water molecules that did not go to our subsurface has a higher chance of becoming surface runoff. So P minus I is equivalent to R. This equation may be written as the summation of I minus V times delta T, or the change in time, is equivalent to the runoff depth. Okay, so the first thing that we need to solve first here would be the runoff depth. So for the runoff depth is equivalent to the runoff volume divided by the area of the watershed. Okay, so what what is our runoff volume? Our runoff volume is equivalent to this. So this is our runoff volume, 228.7. And that is in acre feet, divided by the area of the watershed. So what is the area of the watershed? It is equivalent to 0.875 square miles. 0.875 square miles. But take note here that our unit should be consistent. It should be in acre or miles or miles. It cannot be acre and mile squared. Okay, so we cancel the mile. So for every 1 mile, we have 640 acres. I repeat, for every 1 square mile, we have 640 acres. So therefore, the runoff depth is equivalent to 0.4084 feet. Okay? And that is equivalent to 4.9 inches. Okay. Now, by using or by substituting this to our equation, the summation of I minus phi is equivalent to 4.9 inch, we can now determine the phi index by trial and error. By the way, this method is a trial and error method, no? So, you should be patient or in doing this and at least have a good estimate. Okay? Yan. So, for this one, let's try to use 1.2 as our phi index. So, ang mangyayari, iisa-isahin natin yan. So, 1.4 minus 1.2. Now, as much as possible, your phi index should not be greater than your first, should be greater than the first intensity, inch per hour. Because if that would be greater, then ibig sabihin hindi umulan. Kumbaga, nabawasan pa siya ng tubig, 'di ba? Nag-sip pa siya nag-suck pa siya ng water sa surface natin. So that is not possible. So as much as possible, kasi kumbaga ito, nagkaroon tayo ng rainfall at 0 to 1. So there is a rainfall here. Okay? So kaka-start. So ibig sabihin, hindi pwedeng hindi mag-penetrate sa soil. Okay? So, as much as possible, the phi index should not be greater than 1.4. Okay? So, we assume here 1.2 inch per hour. Substituting it to our equation, we have it 1.4 minus phi. That should be minus. So, minus phi times our time of 2 hours. Because that is from 0 to 2, that is 2 hours. Okay? So, times 2 plus we have here 2.3 minus phi. So 2.3 minus phi plus times the time of what is the time. So from R2 to hour 5, that is 3 hours. So that is time equivalent to 3 hours. Plus we have it here 1.1 minus phi times 5 to 7, that is 2 hours, 0.7 minus 1 phi times the hours from 7 to 10, that is 3 hours, then 0.3 minus phi times the hour. So actually ito yon. So we have it here 1.4 minus phi times 2 hours, 2.3 minus phi, that is equivalent to 3 hours. Okay, now the thing here is my assumed value, by the way, we equate it to 4.007 inch. Okay? Now, the thing here is, my assumed phi index here is equivalent to 1.2 inch per hour. So, ang mangyayari, since 1.1 minus 1.2 is 0, I am no longer going to include this equation. Likewise with this equation, because 0.7 minus 1.2 is negative, 0.3 minus 1.2 is also negative. So, I am going to exclude all of these three equations. Okay? So, bring out your calculator. 1.4 minus alpha x times 2 plus 2.3 minus 1.2 times 3 is equivalent to ilan? Is equivalent to 4.9. Shift solve. no, wait. We have 1.4 minus alpha x times 2 plus 2.3 minus alpha x times 3 is equivalent to 4.9. And that is equivalent to 0.999 or 96 rather 0.96. Now 0.96 is still far from 1.2. Dapat mag-i-equate si 1.2 and si 0.96. Since hindi equate si 1.2 and 0.96, I will be assuming again another value for phi index. Okay? So, let's try 1. Okay? So, i-assume natin si 1. So, if I am going to assume 1, I will be inputting the same equation. So, 1.4 minus phi times 2r's, pwede because 1 is below than 1.4. 2.3 minus phi, okay. 1.1 minus phi times 2r's, that is still okay. But 0.7 minus 1 is negative. 0.3 minus 1 is also negative. So, what I'm going to do is exclude these two equations. So, I am going to input these three equations in my calculator, equated to 4.09. And ang lalabas dyan, idagdag natin yung third equation, which is 1.1 minus alpha x is equivalent to 0.999 ang lumabas. And 0.999 is almost equivalent to 1.0. Therefore, my phi index, the assumed value of 1 is correct since nag-equate na si phi index at saka si assumed value. Okay? Thus, plotting it now to our, we can now plot it to our hyetograph so we can check the losses and the excess. Okay? So, ang gagawin natin, we have here sa y-coordinate and we have here sa x-coordinate. So, for the y-coordinate, we have here the rainfall, and for the coordinate, we have here the time. Okay? So, ito yung rainfall natin, 1.4, 2.3, 1.1, 0.7, and we have here 0.3. Okay? So, ipa-plot natin. From 0 to 2, the rainfall is 1.4. From 2 to 5, it is 2.3. From 5 to 7, it is 1.1. From 7 to 10, it is 0.7. From 10 to 12, it is 0.3. So, ipag-plinat natin yan, ayan o. Sa first 2 hours, it is 1.4. From 2 to 5, it is 2.3. From 5 to 7, it is 1.1. From 7 to 10, it is 0.7. And from 10 to 12 rather, it is the, what do you call this? It is 0.3. Now, yung value natin na phi index, we are going to plot that, connect it by a dash line. So, everything that is above the dash line, ito na yung ating runoff. This is our runoff. While the values below, here is the excess. Or it is the, it is not excess. It is the infiltration losses. Okay, so that's how we are going to draw create our hyetograph. So, yun yung sabi dito. Similarly, the volume of infiltration losses can be easily be estimated by solving the shaded area under the plot of the phi index and multiplying it by the watershed area. So, determine natin yung volume. Kunin lang natin yung volume nito. We can get that volume and i-multiply lang natin sa watershed area. Yun na yung volume of infiltration losses. Okay? So, ganun din sa ating surface runoff or runoff water. So, it is the area of the shaded above the phi index, then multiplied it by the area of the watershed. Then, the duration of the rainfall excess that is 7 hours long is also visible from the hyetograph. Okay, so this is the 7-hour long tinutukoy natin. So, kung gusto natin Kung gusto natin malaman yung infiltration losses natin, ito yon. So, it is below the line. So, kunin lang natin yung volume. We have 1 times 7. Then, dito naman, 1 times itong total area dito. So, I repeat, sa taas, it is the runoff, while sa baba, it is the losses. Okay? Substituting it to our equation, we have it 1.4 minus phi. That should be minus. So, minus phi times our time of 2 hours. Because that is from 0 to 2, that is 2 hours. Okay? So, times 2 plus we have here 2.3 minus phi. So, 2.3 minus phi plus, times the time of, what is the time? So, from R2 to hour 5, that is 3 hours. So, that is time equivalent to 3 hours. Plus we have it here, 1.1 minus phi times 5 to 7, that is 2 hours. 0.7 minus 1 phi times the hours from 7 to 10, that is 3 hours. Then 0.3 minus phi times the hour. So, actually, ito yon. So, we have it here, 1.4 minus phi times 2 hours. 2.3 minus phi, that is equivalent to 3 hours. Okay? Now, the thing here is, may assumed value, by the way, we equate it to 4.0007 inch. Okay? Now, the thing here is, my assumed phi index here is equivalent to 1.2 inch per hour. So, ang mangyayari, since 1.1 minus 1.2 is 0, I am no longer going to include this equation. Likewise with this equation, because 0.7 minus 1.2 is negative, 0.3 minus 1.2 is also negative. So, I am going to exclude all of these three equations. Okay? So, bring out your calculator. 1.4 minus alpha x times 2 plus 2.3 minus 1.2 times 3 is equivalent to ilan? Is equivalent to 4.9. Shift solve. No, wait. We have 1.4 minus alpha x times 2 plus 2.3 minus alpha x times 3 is equivalent to 4.9. And that is equivalent to 0.999 or 96 rather. 0.96. Now 0.96 is still far from 1.2. Dapat mag-i-equate si 1.2 and si 0.96. Since hindi equate si 1.2 and 0.96, I will be assuming again another value for phi index. Okay? So, let's try 1. Okay? So, i-assume natin si 1. So, if I am going to assume 1, I will be inputting the same equation. So, 1.4 minus phi times 2 hours, pwede, because 1 is below than 1.4. 2.3 minus phi, okay. 1.1 minus phi times 2 hours, that is still okay. But 0.7 minus 1 is negative. 0.3 minus 1 is also negative. So, what I'm going to do is exclude these two equations. So, I am going to input these three equations in my calculator, equated to 4.09. And ang lalabas dyan, idagdag natin yung third equation, which is 1.1 minus alpha x is equivalent to 0.999 ang lumabas. And 0.999 is almost equivalent to 1.0. Therefore, my phi index, the assumed value of 1 is correct since nag-equate na si phi index at saka si assumed value. Okay? Thus, plotting it now to our we can now plot it to our Hayato graph so we can check the losses and the excess. Okay? So, ang gagawin natin, we have here sa y coordinate and we have here sa x coordinate. So, for the y coordinate, we have here the rainfall and for the coordinate, we have here the time. Okay? So, ito yung rainfall natin, 1.4, 2.3, 1.1, 0.7, and we have here 0.3. Okay, so ipa-plot natin. From 0 to 2, the rainfall is 1.4. From 2 to 5, it is 2.3. From 5 to 7, it is 1.1. From 7 to 10, it is 0.7. From 10 to 12, it is 0.3. So, ipag-plinat natin yan. Ayan, no? Sa first 2 hours, it is 1.4. From 2 to 5, it is 2.3. From 5 to 7, it is 1.1. From 7 to 10, it is 0.7. And from 10 to 12 rather, it is the, what do you call this? It is 0.3. Now, yung value natin na phi index, we are going to plot that, connect it by a dash line. So, everything that is above the dash line, ito na yung ating runoff. This is our runoff. While the values below, here is the excess. Or it is the, it is not excess. It is the infiltration losses. Okay, so that's how we are going to draw create our hyetograph. Kung gusto natin malaman yung infiltration losses natin, ito yon. So, it is below the line. So, kunin lang natin yung volume. We have 1 times 7. Then, dito naman, 1 times itong total area dito. So, I repeat, sa taas, it is the runoff, while sa baba, it is the losses. Okay? So, pag pinasolve kayo ng volume of infiltration losses, just simply get the area of this shaded part above times the area of the shaded below times the area of the watershed. Then for the rainfall excess, volume above times the area of the watershed. Now, for the methods of measuring infiltration, we have here different methods. So, check this video here. The link is on your manual or on your module. So, check it out there. Okay, so doon i-demonstrate and makikita nyo yung use ng infiltrometer. Okay?